Hello everyone, I'm François from Shakmat, and this is the Centaur's Gates, and we are here to demonstrate how it works. The Centaur's Gate is a dual multi-type gate. It has two identical channels which can shapeshift into different types and modes of filter or VCA or low-pass gate. Here you can select a type, so basically what the channel is doing, it's for the first channel. And here for the second channel, we have of course control upon the frequency or level, here for the resonance of feedbacks, CV attenuation for the frequency, and of course we have the same for the second channel over here. The Centaur's Gates has a fully analog signal path and has a digital brain which allows to reconfigure all the analog blocks. Let's now have a closer look at the frequency/level control of the Centaur's Gates. First, you have a dedicated potentiometer for the frequency control of the VCF or the level of the LPG or VCA. You can also control the frequency/level thanks to two CV inputs, frequency level and CV1, which is a dedicated attenuator/attenuator. We are sending an envelope from a triple staple into CV1. Let's turn the CV potentiometer up. Each CV potentiometer has an attenuator switch, allowing to turn this potentiometer from attenuator to attenuator. Let's switch to attenuator. Like any attenuator, at noon we have a full attenuation. Let's turn the potentiometer clockwise and we will increase the amplitude of the modulation. Back to noon you have full attenuation, and when we turn the potentiometer counterclockwise, we are now increasing the amplitude of the modulation, but with a phase inversion, meaning the amplitude of the envelope is now negative. Let's switch now to VCA mode. So we have a manual control of the level of the VCA. So let's modulate with the envelope the VCA level. We are still in attenuator mode, so we can now invert the envelope. Let's now have a look at the resonance/feedback control. So the first channel is set as a low pass filter. Let's open the filter and let's increase the resonance. By the way, resonance has also a CV input. For the LPG and VCA, this potentiometer sets the amount of feedback. We will have a more in-depth review of this feature in the type section of this video. Let's now talk about channel linking and CV normalization. In this configuration, the CV input of the second channel is normalized to the CV input of the first channel. Right now the first channel is a low-pass filter, as the second channel is a low-pass gate. So again, we will use the triple steeple as a modulation source, and we are sending the output of the first channel of the triple steeple into the CV1 of the Centaur's gate. Let's open the second channel and let's turn the CV1, so the attenuator of the first channel. Okay, let's now open the filter of the first channel and close the LPG, and thanks to the normalization on CV2, we are now modulating the amplitude of the second channel. Let's now talk about the link feature and the way the CV2 input is normalized to the modulation sent into the first channel. So let's switch the second channel in the pass filter as the first channel. In link mode, the first channel will be the master control of the whole module, as the second channel will be bipolar offsets. So we have to put that in noon if you want to have exactly the same control on the channel 2 and channel 1. With this configuration, we will easily create a 4-poles filter. So of course, we have to engage the link control over here. When the link control is engaged, the CV2 input is normalized to the modulation received into the CV1 input post-attenuation or attenuation. In our application, we want both channels to have the same modulation signal, so let's turn this potentiometer fully clockwise. As the CV2 input is receiving the modulation signal post-CV1 attenuation, we have now to turn CV1 in order to modulate the two channels the same way. So again, this controls the resonance for both channels. This potentiometer controls the cutoff frequency for both channels. Let's put a bit more resonance on the two last poles. So again, resonance feedback and frequency level of the second channel are bipolar offsets. So if you turn this potentiometer below noon, you will have a lower cutoff frequency for the two last poles. Let's now have a look at the different types of the Centaur's gates. So again, types define the way each channel behaves. First channel is set as a green low-pass filter, which is a smooth and warm low-pass filter. We can switch it in band-pass filter, high-pass filter. And the fourth option for the green type is the low-pass gate. To switch to the second family of types, you have to press the active type, and you are now in the red family types. In the red family types, we have now a more aggressive type of filters: low pass, band pass, high pass, and VCA. Let's listen first to the green filters. So we have 2 poles VCF with a gentle and never self-oscillating resonance. Green filters have a smoother character when you reduce the input gain to -5 dB. Let's switch to the bandpass. High pass. low pass gate. We'll come back to the low pass gate in the Opto section of this video. Feedback on the LPG gives a volume boost, which is pretty useful for accents. Let's now switch to the red family, so low pass filter. Let's go back to a 0 dB gain. Let's put some resonance. As you can hear, the resonance in the red family type is a bit more aggressive. Okay, let's switch to the red bandpass. Red high pass. Fourth option for the red family is the VCA. Let's switch to a sine VCO because the feedback for the VCA is a parallel distortion with a feedback loop. So let's turn this potentiometer up. You can hear at low level we have a parallel distortion. And at higher level we have feedback. So even if we remove the input, we still have the feedback happening. Each channel of the Centaur's gate has a CV input for the type. This means you can select your type thanks to an offset, or also create patterns or send LFO into the type CV input in order to dynamically change the type. So we have a Harlequin's context output into the type CV input. Let's switch back to our 0 dB gain. As you can hear, the type switching is clickless as each channel listens to its output waiting for zero crossing in order to change its type. Let's switch back to more distorted settings, and we will use now the Harlequin's context in knob recording mode in order to sequence the types. Let's also sequence the type of the second channel, still with knob recorder from the second channel of the Harlequin's context. As we mentioned earlier in this video, each channel of the Centaur's gates has a gain setting. To set the gain, use the in button along the three LEDs. We have three different settings: -5 dB, 0 dB, and a drive option. Gain is pretty important because it can really change the character, the way each filter reacts to any incoming signal. Let's first listen to the green filters with a null attenuation, so 0 dB attenuation. Let's switch now to the drive mode, and yeah, let's go for a saw, maybe from the VCO. Let's also drive the second channel. Let's now listen to the filter with a -5 dB attenuation for each channel. As you can hear, reducing the input gain really changes the way the green filter sounds. Let's go to the red filters now. So with input attenuation, we have more room for the resonance. Let's now switch to 0 dB attenuation. In order to have more extreme results, let's switch to the drive. The Centaur's gates provide serial or parallel configurations. In serial configuration, the second input is normalized to the first output. For a lot of patches, it's pretty convenient, as you just need to send a signal in the first input and take the second output. One of the first applications we can think about in serial configuration is having a low-pass filter and a high-pass filter in serial. Let's now switch to the parallel configuration by pressing for 2 seconds the link button. In parallel mode, the second input is normalized to the first input. Also, when no cable is inserted into the first output, the second output provides the sum of the two channels. So let's take a patch cable and insert it into the first output. As you can hear, we removed the first channel from the second output. Using the two outputs at the same time is, for example, a good solution in order to create mono to stereo patches. We'll get back to this at the end of the video in the patch example section. So now we are back using just the second output, which provides the sum of the two channels. Using a low pass and a high pass at the same time give you a variable width notch. Let's extend the width of the notch. Let's narrow the notch, and let's go to have both potentiometer at the same position in order to have a very narrow notch. We can of course use the link function, so the frequency level setting of the first channel is the frequency of the notch, as the second potentiometer is the width of the notch. Another great application of the parallel configuration is to set both filters in bandpass mode. And we'll go for the red bandpass, and we have a dual peak filter. We are still in link mode, so the frequency control of the first channel will move the two bandpass at the same time, as the second channel frequency level control sets the frequency difference between the two bandpass. A pretty handy Centaur's gates feature is the Opto mode. The Opto mode is an analog emulation of the behavior of the infamous vactrols. Vactrols have a pretty slow response to CV signals. In other words, they are kind of giving a slow limiter on the incoming CV signals, resulting a very nice and natural decaying envelope. In this patch, we are sending from a triple steeple a very short gate, more like a trigger, with an 8-volt amplitude. The triple steeple is sequenced by a 4-bit rook, and we are going to listen first to the way the Centaur's gates react without the Opto mode activated. So let's turn the Opto mode on. And of course, let's listen to the Opto mode with a low pass gate. The Centaur's gates handles the select bus protocol. Using the select bus along with the Centaur's gates allows to create 16 presets from a select bus transmitter like the Harlequin's context. Presets includes the type of each channel, the link feature, the serial parallel configuration, the Opto mode, the attenuator mode, and the input gains. So we have a first Harlequin's context, which is the select bus transmitter, and we will use a second Harlequin's context in order to create a sequence for a VCO. I'm now creating a first preset. So let's activate the attenuator on the second channel. Let's set the second channel in high pass mode. So let's say it's my first preset. We're gonna store it thanks to the Harlequin's context. And as you can see, the Centaur's gate just reacted to the store message from the Harlequin's context. Let's now create a second preset. You can of course use also the output of the Harlequin's context, which is select bus transmitter, to control the different parameter. We will store this preset on the second scene. Let's switch back to the first preset. Second preset. First preset. And second preset. We can of course create now a third preset. Let's switch to parallel configuration, different filters, attenuator mode for both channels. Let's now engage also the Opto mode, and we will create a third preset. And now we can switch through all 3 different presets. The Centaur's gates has an option menu which allows to customize different settings of the module. To enter the option menu, you have to press for 4 seconds on the 2 input buttons. While in the option menu, as you can see, there are different LEDs blinking. First thing you can set is zero crossing anti-click of the type switching. Thanks to the Opto button, you can independently enable or disable the anti-click per channel. LED on means the anti-click is activated. LED off means the anti-click is deactivated. Second setting is enabling or disabling the select bus thanks to the link button, which is on when the select bus is activated. Last setting is 2 different modes for the LPG. If the LPG LED is green, we have a -6 dB per octave LPG, and when pressing on the button, you can turn it into a 12 dB per octave LPG. To exit this menu and store the settings, you have to press the first input button. If you want to create the menu without saving, you have to press the second input button. Let's now have a look at different patches and different ways to use the Centaur's gate. First, we will focus on different ways to use the Centaur's gate in serial mode. So we will do a simple patch by taking our Banshee reach, which is our analog VCO, into the first channel of the Centaur's gate, and we will listen to the second channel output. Right now we have a VCF for the first channel and a VCA for the second channel. Let's also take some modulation coming from the triple steeple that will be clocked by the clock upon. So we have a envelope coming out from the triple steeple into the CV1 input of the Centaur's gate. So again, there is a normalization for CV, meaning that CV2 is normalized to CV1. So we have the control on the VCA and here the control on the VCF. Let's now go to a second application and we will set the second channel now into green filter. So we have the same kind of filter on both channels. So now we have 4 poles filter. So for this application, let's turn on the link mode. When link is engaged, channel 1 is a master, as channel 2 will be an offset for the parameter of the second channel. So this controls the frequency of the 2 filters. In link mode, if you turn the second CV potentiometer fully clockwise, we will have the control of the 2 channels only using the first CV potentiometer. Okay, let's now switch to another application, which is the low pass and high pass combo. With a link engage, we have more like a band pass with a control on the bandwidth. So channel 1 frequency controls the frequency of the band pass, as the channel 2 frequency potentiometer controls the bandwidth. Again, let's try with different gain. Green filters and -5 dB gain attenuation works pretty well to me. Third serial patch ID, let's switch to the red filters. Actually, I prefer to have the high pass before the low pass in this configuration. Let's switch back to 0 dB or even drive. And you have something similar to the filter section of an MS20. Let's now see some other patch IDs, but this time in parallel configuration. First application would be a notch, so we have different type of filters, a low pass and a high pass that are summed up. So again, you can use a link function. So first potentiometer will be the center frequency of the notch, as the second potentiometer will give the notch width. Check out another application we saw earlier in this video. We will configure both channels in band pass mode, and we are creating now a dual peak filter. Again, if I don't insert anything in the first output, the second output provides the sum of the 2 channels. I personally much more enjoy the dual peak filtering with the red filters, which are more resonant and a bit more aggressive. now see other applications of the parallel configuration. This time we will do stereo patches. So again, in parallel mode, the second input is normalized to the first input. So we are in link mode, meaning that the first channel is a master control as the second channel provide offsets for the settings of the second channel. So channel 1 gives the controls of the stereo filters, as channel 2 control will set the panning of the filter. Now we can hear the kind of panning of the filter. Let's put more resonance on the right side. Now the Centaur's gate is used as mono to stereo, but basically we can process stereo signal using the two inputs. So let's switch now to a more classical panning, so panning with amplitude. So let's switch to VCA mode. So let's use an LFO from Harlequin's context. Let's choose sine LFO. So again, in link mode, the second channel CV input is normalized to the signal from the first CV post attenuation. So now we have the same modulation signal on both channels. But we can press the attenuator on the second channel and turn the potentiometer fully counterclockwise, so we have an inverted CV signal on the second channel. And as you can hear, we have now a panner, and the CV control on the first channel will set the depth of the panning. You can of course try this with different types, like panner with LPG, or even with low pass filter. You can add a bit of resonance. Let's now check a couple of patches that use the Centaur's gate as a sound source. So first ID, let's turn the first channel into a sound source, a pingable sound source. So low pass filter red with quite some resonance will give great result when pinged, and we use the second channel in low pass gate mode. So let's use a trigger from the accent output of the clock upon. We will send it into a triple steeple in gate mode with very short rise and fall time. So we have a trigger with an 8-volt amplitude. Let's send this into the CV2 input. So we will ping the LPG that we will place in Opto mode later, and we will also ping the audio input of the first channel. So let's open this low pass gate so we can hear what's happening with the pinged filter. Let's tune it. Of course, you can switch the mode, so you have different sonic results. Let's now close the LPG and activate the Opto mode. We can add a bit of FM to the first channel, so we will hear how the filters sound when resonant and with a bit of FM. Let's go to another trigger pattern. Let's also clock an Harlequin's context, so we have a sequencer when using the Harlequin's context in knob recording mode. Let's create kind of a melody. Okay, let's now have a look to a second patch. This time we will turn the Centaur's gate into a kind of chaotic tone / noise generator. So basically what we're gonna do here is to send the second output into the CV control of the channel 1, and likewise we will send the first output into the CV control of the second channel. So basically we are doing cross FM and we will use the red filter types. Let's go in drive mode for both channels. So we are in serial mode, meaning the first output is going into the channel 2 input, but we can also create more feedback by sending the output of the channel 2 into the input of the channel 1. Let's switch to other types. We have different results. And of course, you can also sequence type with an harlequin's context in a recording mode. You will easily create sequences. Thanks a lot for watching, see you soon, and bye bye.